Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to start discussion on Amazon Managed Streaming for Apache Kafka. Okay, from the name itself you can understand what this service is used for. If you want to securely stream data with fully managed highly available Apache Kafka service, then you can go with MSK, right? So the zookeeper part, the brokers part, we no need to worry. Our AWS will take care of those. Only we need to set up the connectivity using bootstrap strings or the broker URLs, and then we can create topics and publish data using Python or Java client or using Kafka REST proxy or using some other mechanism. Okay, right? So let's try to create a very simple MSK cluster, and we will create producer and consumer, and we will try to publish the data in the cluster, and we will try to consume the data from the particular topic. And that way we will have some fundamental idea about Amazon Managed Streaming for Apache Kafka. Okay. So before going ahead with today's discussion, I will request you to go through my previous videos where I have explained the networking concept in detail, because VPC, Subnet, then route tables, then internet gateway, all these concepts are required to create the MSK cluster. Okay, because MSK cluster we will launch within a virtual private cloud. So for that we will create a VPC first. Within that VPC, to make our MSK or Kafka cluster highly available, we will launch two brokers in two different subnets or two different availability zones, so that if there is some problem with one AZ, the other AZ can handle the workload, right? So you need to have a clear idea on the networking part. Already I discussed several concepts related to this topic in detail. I will be sharing all the prerequisite link in the description box or in the comment section. You can go through that. Okay. So without any further delay, let us directly start the steps to create the network for our Kafka cluster. So first step, what we will do, we will create a VPC. Okay. And the name we can give virtual private cloud or MSK VPC, whatever. And we will provide the IPv4 CIDR range, that is 10.0.0.0/16. That means 10.0.0.1 to 10.0.255.254. This much range of IPs we are allowing for this VPC. Okay. So because here I am giving /16, so that means the last two positions, last two octets can be used. So octet minimum value will be 0 and maximum value can go to 255, right? So from 0.1 to 255.254, this is the range of IPs what our this VPC can accommodate. Okay. Then what we will do, we will create two subnet within the VPC, one having the name public subnet A, another one public subnet B. Obviously, we will configure the IP range such that they will not be overlapping. For the first one, we will provide the IPv4 CIDR as 10.0.0.24. That means 24 when I am saying means that first three octets we cannot use. Only the last octet can be used. So starting from 0.1 to 0.254, this range of IPs our public subnet A can use, and for public subnet B we are changing the value for this particular location, and we will be providing the IPv4 CIDR range as 10.0.1.0/24. That means from 1.1 to 1.254, this is the IP range for our public subnet B can accommodate. Okay. And then obviously when we are creating VPC, we'll be having a default route table also, and we will observe that both of these subnets will be associated with the default route table of the VPC. Obviously we can create route table for individual subnets, but that is not required for in this particular experiment. And then what we will do, by default the route table will be configured such way that the local subnets with respect to that VPC can communicate between each other. That means this public subnet A can communicate with public subnet B. But suppose you want to communicate via internet, so obviously that time we need IGW. So we will create an IGW and connect with our VPC, and then we will add the IGW with our default route table which is associated with our VPC, so that if any traffic is coming from internet, our route table can handle that. Okay. And once it is done, then we will launch our MSK cluster with all these networking configurations what we will be doing from step 1 to step 5, right? So this is about the networking idea. I will quickly do that. So first step, we will be creating a VPC. So for that, what I will do, I will log in my AWS Management Console, and here I will go to VPC and I'll be creating a VPC. So here VPCs, create VPC, and here VPC name maybe I can give virtual private cloud only, and the IPv4 CIDR will be providing this range. Okay, so here we have keeping all other properties as default. We will be creating the VPC. Then the next step will be creating two public subnets, right? So here we will go to subnets, and then here create subnet, and then VPC. So first here we need to choose the virtual private cloud what we just now created, and then here we will give the name of our first subnet as public subnet A, and then here we will provide the IPv4 range. Okay, so here I have given the IPv4 range for our first public subnet, and then here I will create the subnet, and then here I will create another subnet, public subnet B, within our VPC virtual private cloud what we launched. Okay, and then here what I will do, I will configure the range for our this second public subnet. Okay, right? So here I will create the subnet. Okay, now these two is done. Now we will observe the default route table which is associated with our VPC. Okay, so we will go to our route tables, and here if you see there are two route tables. One is for the default VPC which is by default available in all AWS account, and another one route table which is created for our VPC which is having the name virtual private cloud, right? So we will go to this particular route table, and here we will see that local access it is allowing. That is, those two public subnets can communicate or talk between each other. Okay, if you go to subnet association, explicitly nothing is added. By default, these two subnets, as they are coming under the main VPC, and this route table is associated with our VPC, so by default these subnets will be having this route connection, obviously, right? Now what we will do, once the route table we have observed, we will create an internet gateway so that our VPC can communicate with internet. So for that I will go to internet gateway and create internet gateway, and here I can give the name as my IGW. Okay, and then here I will create the internet gateway, and this particular internet gateway I will attach with the VPC what just now we created. Okay, that is this one. We will attach that, and then what we will do, we will configure in route table so that our route table will be forwarding all the requests via this IGW whenever it will be coming via internet, right? So we will configure that. So here I will go to route tables, and then this is our route table, and what we will do, we will edit the route, add the route from internet. If the request is coming, then it should go to internet gateway, and this is my IGW what just now I created for this particular VPC. So what we will do, we will save the changes. So that way our more or less the networking part is done. Now the next step is we will launch MSK cluster with the VPC what we just now configured, and we will give unauthorized access. Okay, so that when our client system, that is producer or consumer, will try to connect with our cluster, no need to configure any trust store or key store explicitly. Unauthorized access as of now we are doing, because just now we are trying to understand the foundation of MSK. Eventually in our upcoming videos we will understand about the security part in detail. Okay, and we are not configuring any encryption specifically. We will be keeping plain text encryption. Obviously this is not secure, but as we are doing POC, so it can be used. Okay, now what I will do, I will open AWS Management Console in a new tab, and I will launch one MSK cluster, right? So here create cluster, I will go to custom create cluster name demo YT test 123, some name I have given. I will be configuring provisioned cluster. Apache Kafka version, this is recommended, so we'll be keeping as it is. Okay, now what should be the broker type? That is our actual Kafka server, right? When it will be running, in what kind of machine it should run. So as of now we are doing POC, so what we will do, we will keep the minimum configuration, that is Kafka T3 small. Okay, now here we need to make our Kafka cluster highly available. Okay, that is multiple brokers or multiple servers should be running in different zones, so that if one zone has some issue and that particular server is down, other server can handle the payload. Okay, so here we created two different subnets, right? So let me just show you. So here if you see, our first public subnet or public subnet B is sitting in US East 1E, and our another subnet A is sitting in what region? That is also same AZ. Okay, so we need to create in different AZ. So what I will do, I will select this one and maybe I will delete this subnet. Okay, I will create that subnet again. So public subnet B I am deleting, and what I will do, I will create the subnet and VPC I will be choosing, and then here subnet name I can give as public subnet B. Okay, and then here this is the IP before CIDR. Okay, here we can choose maybe US East A. So our earlier one, let me just confirm once more time. That is our public subnet A. It is sitting in US East 1E region. So our public subnet B should be in some other AZ, right? So we are configuring in US East 1E. So that means they will be in different zone. So that is fine. So here we have created both subnets, and obviously I think cloud table will be updated automatically. Let me just confirm. So here local it is there and subnet association. So public subnet B and public subnet A both are, that is fine. So our both subnets are in different zones, so we will choose that. So we created two subnets, so we will choose number of zones as 2, broker per zone 1. So that means we have created two subnet. In both subnet, one server will be running, and basically this number is indicating in one zone only one server will be running. So your cluster has two total brokers distributed evenly across 2 AZ. Okay, as simple as that, right? This configuration we will make it lesser, maybe 1 GB. Okay, and then here EBS storage only, that is fine, and default configuration only we are keeping, that is fine. Now we will choose our virtual private cloud what just now we created. The zone A should be maybe, for example, US East 1E, where we are having one subnet, that is public subnet A, and another zone can be US East 1A, where we are having our public subnet B. Okay, so both the subnets we have configured. As of now both are public access off, this is configured, that is fine. The security group, what we will do, we will not create security group. By default let it create the security group. So I will go to next. Unauthorized access I am allowing, not a problem, and the encryption I am allowing the plain text encryption. Okay, later we will go to SSL or SCRAM based authentication, etc, right? So those things will be coming later. As of now we are keeping it very simple: unauthorized access and plain text authentication. AWS managed key, we using that, we want to encrypt the data, that is fine. Now I will go to next. The monitoring section I am keeping as it is, no change. I will click on next. Now here we can review our setup. So this is the cluster name, cluster type is provisioned. This should be our Apache Kafka version. The broker type we are choosing P3 small and 1 GB of EBS, right? And then here MSK default configuration only we are keeping in two different subnets. With this security group our cluster will be launching. Okay, unauthorized access we are keeping as of now, and more or less it is looking good. What I will do, I will create the cluster. If you see here, it is clearly showing a typical provision cluster takes up to 15 minutes to create. So we need to wait that 15 to 20 minutes, and once our cluster is ready we will start it again. So here refresh the page and try and if problem persists. Here I think some issue happened. Let me just refresh this page. I think some configuration issue happened. Let me just give the cluster name again. Demo test 123. Okay, provisioned Apache Kafka cluster. Broker should be T3 small. Okay, number of zones 2 I am choosing. Broker per zone is 1. Okay, this volume I am configuring to 1 GB, right? And then here MSK default configuration, that is fine. VPC we will choose our VPC which just now we created. The zone first one I will choose, and within that we create a public subnet A. The US East 1A we will choose, which is a separate zone, and there public subnet B is there, and I will click on next. Unauthorized access and plain text authentication we are keeping. Maybe IAM based authentication is not required as of now, only let's keep unauthorized access, right? And then we will click on next. This is fine, next, and let's create the cluster. Okay, so here it is showing one or more subnet belong to unsupported AZ US East 1E. Okay, right. So we need to change the AZ for that. In that particular AZ, our this MSK support is not there. So I think public subnet A is in that region, right? US East 1. So we need to create this public subnet A once more time. So that is not at all a problem. So what I will do, I will delete the public subnet A. And let me just create the subnet within our VPC. This is the subnet name. Maybe I will choose US East B. Okay. Our public subnet B is in US East A. Our public subnet A is in US East B, like that. Okay. And public subnet A, I will choose this particular configuration. Okay. And then here I will put this subnet. Right. So our subnet is created. Let me just try to do it again. We'll go to previous. And here I will choose public subnet B. Okay. There our public subnet A is running. So in US East B, our public subnet A is running, and in US East A, our public subnet B is running. Now I think it should work. Let's see. So here if you see, our cluster is getting created. So we need to wait 15 minutes till the cluster is ready. Okay. So now our cluster is active. Okay, right? So we can start using this particular cluster. So let's go through the next steps, what we have to perform. So first what we will do, we will launch an Linux EC2 instance, and that EC2 instance we will launch within the same virtual private cloud what we have used for our MSK cluster. Okay, and obviously we will assign one public IP to this EC2 instance. So let's do that. So here I will open AWS Management Console in a new tab, and I will click to EC2. Okay, and here I will launch one EC2 instance. So here instance, and then here I will launch instance Kafka client. So here this EC2 will be using to produce data or to consume data, etc. for this demo purposes. Okay, so here Linux machine I am choosing, right? T2 micro is fine. Key pair, I am having one existing key pair, so I am choosing that. The VPC, I will choose the VPC what just now we created, that is virtual private cloud. And then subnet, maybe let's launch in public subnet B, that is not a problem. Auto assign public IP, we will enable that, and create security group. So let AWS create the security group for our EC2, and later we will do some modifications in this security group so that our MSK cluster and this EC2 can communicate between each other. Okay, right? So here this security group I am keeping, and then keeping all other properties as default, I will launch the instance. Okay. So once our cluster is ready, what we have to do? We have to configure the security group such that all the traffic our MSK cluster will allow from the EC2 instance, and our EC2 instance will also allow all the traffic from our MSK cluster. So that's what I have written here. You can go through that. Let me just show you, then you will be getting much better idea. You can pause the video and try to understand this particular thing, what is written. But I am doing the same thing now in the console. Okay. So here our EC2 is launched, right? So here I can click on this EC2, and then here in security group, we will edit the inbound rule. So this is the security group for our EC2. So what I will do in the inbound rule, I will edit the inbound rule, and I want to make sure that from MSK cluster, all the traffics are allowed to our EC2. So what I will do, I will make all traffic, and here I will put the security group for our MSK cluster. So I will just take the security group from my MSK cluster, and here this is our security group. I'll copy that. I'll just paste that here. Okay. So that is done, and I will save the rule. So now here what we have configured, that from MSK cluster all the traffic should be allowed to our EC2 instance. Okay. Similarly, the reverse way also we have to do. That is, for the MSK cluster, this is the security group. We will open the security group for our MSK, and here we will edit the inbound rule, and then here we want to make sure to our MSK cluster all the traffics should be allowed from EC2. Okay. So here EC2 security group is basically this one, right? So here maybe I will copy this particular, or maybe I can go to EC2 instance only, and then click on that, and I can take the security group for our EC2, that is this one. I'll copy that one, and then here I will go to our MSK clusters security group, and we can add this configuration. Okay, so that way from MSK to EC2, similarly from EC2 to MSK, all traffics are allowed. Okay, so our EC2 client machine and our MSK Kafka cluster will have no problem to communicate between each other. Okay, so step 8 is also done. Now we will install some Kafka codes using which we can create the Kafka topic to our cluster, etc. So those Kafka codes we will be installing in our EC2 machine. That how we normally install Kafka in our EC2, we will follow that step. Okay, so here I can close the security group windows, close this window also. So here this is my EC2 instance. Let's do an SSH for this instance. So I will copy this public IP and here I will open put. Okay, so here what I will do, I will choose the ppk file and then here I'll open this one. Yes, and then here I will log in as EC2 user. Okay, right? So we no need to start any brokers or zookeepers because our AWS MSK is handling that. So we will just create the client machine here to produce some data in our cluster and consume it. Okay, so here to avoid timeout, we will change this to 10 seconds, and that is done. Now here quickly we will install first Java, because we cannot work in Kafka without Java, right? So here I will just install that, and then here what I am doing, I am installing the Kafka. You have to keep this concept very carefully in mind, that you have to install that Kafka only what version you have launched in MSK. So if you see here in MSK, here the Kafka version is 2.8.1, so I am downloading 2.8.1 compatible version only. Okay, so here I will just download that and here I will unzip that. Okay, so here it is unzipped. If I do ls, here you will see this is our unzipped location. So I will just do a cd to that directory. Okay, right? If I do ls, here you will see that bin folder, config folder, etc. The default folders are available. Now using Kafka topic.sh, we can create a topic to our MSK cluster. Okay, all we need to do, we need to configure our bootstrap server properly in this code. Okay, I am creating only one partition and one replication factor. You can increase the replication factor to 2 because we have already 2 brokers running. So if you are keeping, suppose for example, partition 2, so one partition will be in one broker, another might be in another broker. That way fault tolerance can be handled. So we need bootstrap server URL for our MSK cluster. So we will just take that quickly. View client information I can do, and here this is for plain text bootstrap server. These are the URLs, right? So 2 URLs I have copied. If you see here, this is basically one particular bootstrap URL and then comma, then this is the second one. Okay, so let's just create the topic, and the topic name what we are providing is demo testing 2. Okay, you can give any name as per your choice. So here let's see whether it is working or not, and see the topic is successfully created. Okay, now this topic is created within our MSK cluster, right? So no need to think about brokers whether it is running properly or not, zookeeper whether it is running properly or not. This is the beauty of MSK. Just we have created a client machine to interact with the Kafka cluster, and then we can do all the activities. Okay, right? So here what I will do, I will now start a console producer. Okay, so I will just copy this particular bootstrap URL, and here I will just start using Kafka console producer, and I will start publishing messages in that particular topic what just now we created. All we will do, we will just change the bootstrap URL. Okay, so let's start it. So here I will just hit enter. So here our producer started. Okay, here see this arrow is coming, that means it is ready to take the messages. So similarly, let me start the consumer also. So what I will do, I will duplicate this particular session, and then maybe here what I will do, I will log in as EC2 user only, and then here maybe in this particular place our consumer will be running. Okay, so let me just make sure that it is also having 10 seconds as configuration, otherwise we might be getting timeout. So that is there, and now I will go to this particular directory, and here I will start my consumer. Again the topic name I am providing, and the bootstrap URL what we received from the MSK cluster that we are configuring. Okay, and here we started our console consumer. I can just minimize this screen little bit. Okay, so here see, this is our producer and this is our consumer. Maybe I can put hello world. Okay, so suppose I am putting hello world, here see the message is coming. So the producer is publishing the message in the broker which is managed by MSK. From MSK our consumer is consuming that. Hi, this is second message. Okay, for example, here it is coming. Okay, 1 2 3, anything I can pass here in console producer and here in console consumer, it is coming perfectly fine. Okay, right? Now what we will do, in our previous video we have seen how to publish the messages in Kafka cluster using Kafka REST proxy, right? So we will do that particular addition also. So let me just come out of the console producer using Control C. So here now I came out of the console producer, and now what I will do, I will basically install the Confluent. Okay, so that way using Confluent REST we can connect with our Kafka cluster, and using REST API we can publish messages in the Kafka, and that Kafka is nothing but our MSK Kafka, not some normal Kafka which is hosted in EC2. Okay, so here first I am installing our Confluent. Okay, once that is done, we will unzip the Confluent. So here we have unzipped the Confluent. Okay, right? And then here what we will do, let me just check once what is my Confluent directory. If I just do ls, so here, or let me do pwd. So my Confluent directory is this one. So I will just copy that, and here Confluent home directory I will just paste it. Okay, so this particular configuration we have to do. Sorry, this that here. Then slash our Confluent directory is basically this one. Okay, so this is our Confluent home. Perfect. And the next step is the path variable also we need to configure. Do that. So these two configurations are required, and now what we can do, we can configure the Kafka REST properties file before starting our server. Okay, right? So we will do that. So for doing that, we will enter in that particular EC2 using WinSCP, and there we will edit that particular file, or even if you want you can use vi command to edit the Kafka REST properties file. Basically in REST properties we need to configure that what is the broker. Okay, so here I will just take my instance. Okay, I'll paste that here. Username I'll be giving, for example, EC2 user, and then here in the advanced section in the authentication I will choose the ppk file what we have used earlier also. Okay, login, and then what we'll do, we will go to this particular directory. So here I will go inside Kafka, then Confluent, and then from Confluent where we have to go, basically within that etc, within that Kafka REST is there. Okay, so etc, and then here we are having Kafka REST, and then here we'll be having Kafka REST properties. Okay, and here what we need to do, if you see here the bootstrap servers we need to configure. Okay, so we will do that configurations quickly. So our bootstrap server is basically this one. So I will copy first one, and then here instead of localhost this I will paste this one. So, and then I will put a comma, and then here from plain text to this place I will be copying, and then again pasting, and here I will put our second broker UI. Okay, it's this one. Right, so bootstrap server we have configured. For our MSK cluster we will just save this particular one. Okay, continue creating an unknown server, add see whether it is getting saved or not. So it got saved. I can close this file. Let me just pause confirm by opening the file once again. So here it is working. Okay, now to allow that REST proxy accessible via internet, I need to make sure that in this particular EC2 all traffic from external world is allowed. I will just add that property also in this security group. So here all traffic from anywhere IPv4, because we will basically trigger that particular REST proxy from Postman, right? So for that also, in that our client machine, that access should be available. I hope you are getting it. Now once that is done, what we will do, we will start our Kafka restart. Okay, we need to make sure we are giving the path correctly. That is basically, this is the path in this case. So here I will just paste this particular path, and here we will configure our Kafka REST properties. Okay, what we configured, that also we are providing. And then let me start our Kafka REST properties, right? Let's see whether it is working or not. So here if you see that it is waiting for listening to request. Okay, now what we will do, we will basically use our this particular URL http:// here we need to provide basically public IP of our EC2 instance, that is basically there is this one, right? So I will just copy that and I'll paste that here. So this is the URL. So what I will do, I will open Postman and maybe I can make a post request. Okay, cool. Content type we need to configure this way. Right, and then here maybe for example we are publishing as of now this particular data. Okay, in the body part, raw data, JSON data we want to pass. So let's see whether it is working or not. So when I published the message, it is sending the request, and see it sent me this particular offset 3. Why offset 3? Because earlier already in this particular topic demo testing 2 only, we published 2 messages and we are having only one partition. So for the first 2 message, offset 0 and offset 1 is already used. So it is offset 3. So let's see our consumer. See here in consumer, test user came. Okay. So let me just make this Postman little bit small and keep it somewhere here. Here our consumer is running. Maybe for example, I will publish another big message with more key value pairs in the same topic. Okay. So for example, if I am publishing this particular bigger message, let's see. So I will go to body part. Here I'll be pasting that one, and then here my consumer is running. So let's make a send request. Okay. So see that same message, whatever just now we published from producer, it is coming. For example, in this REST proxy, as I already shown you, that we can publish multiple records all together. So let me just pass that one also. Right. So 1 and 2 messages I am publishing, and here if I make a send request, see both the messages are coming in our consumer side. Okay, so this is how we can run Kafka REST proxy and we can publish the messages in our MSK cluster using API. Okay, right? And now let me show you one very interesting AWS blog. So if you see this particular blog, which explains how to govern how your clients interact with Apache Kafka using Amazon API Gateway. So they have beautifully explained that integration of MSK cluster via API. So here if you see this particular architecture, here we will be having our API that we can share to any third-party system, or maybe for example using Postman only we can try. So that API will be creating using API Gateway, and that API Gateway, what it will do, it will, for whatever request or whatever payload or whatever message our third-party vendor or partner will be sending, that API Gateway will push those messages to our Kafka REST proxy or this particular URL actually. Okay. So this is our raw Kafka URL, which HTTP, not HTTPS. Okay. And that Kafka client and REST proxy is running in EC2, just what we did today. And that REST proxy will publish the data in MSK cluster. Okay. So basically in simple words, this particular API we can wrap within API Gateway, and that will be obviously HTTPS. So that will be more secure. And the another advantage is all the functionality of API Gateway also you can avail with REST proxy. For example, IP level filtering, or for example, throttling, quota, bars, all this kind of configuration, IAM level access, API key based security, all this security part, if you want to add in your this particular Kafka REST proxy, then better to wrap this particular main URL within an API gateway API. Okay, so let me just do that one also quickly, so that way this particular architecture will be pretty much clear to us. So here what I will do, I will create an API using our API gateway, and we will try to implement the same. So here I'll just create API and REST API I want to build. You can go through that documentation to understand in more detail. So this is the API name. For example, I am creating some random name I have given. Okay, now here if you just scroll below, here they have explained how to create that API using API gateway basically. So here API type REST API we have chosen. The API name something we can give, and the resource name should be proxy we are entering as of now. So here first we will create a resource name proxy, and then here resource path we need to provide this way. So we will put that. Okay, so resource path we have configured this, and here if you see that select configure as proxy resource. So this particular API gateway will hit our Kafka REST proxy and share the payload. So we need to configure this particular proxy resource, and here what we will do, we will create the resource, right? So our resource is created. Now what should be the integration, or for our API gateway what should be the backend? That is basically HTTP proxy, right? And here we can provide our endpoint URL. Here we can share this particular our Kafka REST proxy URL endpoint, and the ending part should be proxy. So the topic name can be maybe dynamically they can provide, the third party client can provide. For example, now this is demo testing 2. Maybe they want to publish the message in demo testing 3 or hello world, any topic. They can just change this particular part. Okay, like that we are configuring, and then here what we can do, we can save this one. Okay, cool. I think it is pretty much very simple. I hope you got it. And then here what we will do, we will deploy this API. Maybe we will create a new stage development, and here we will deploy. Okay, right? So here this is our base URL. I will copy that and show you. So instead of this particular Kafka raw REST proxy, now we can use this particular API gateway API. Okay, and here after def we need to provide the topic name. So in our case where we want to publish the messages, that particular topic name is nothing but demo testing 2. So I will select that one, right? Keeping all other properties unchanged. Maybe for example, as of now, let me pass a very simple record. What I can publish like this kind of raw record just to show you, and later we can test with some complex data. For example, I can pass 1, 2, 3. Okay, right? So let's see. Here our consumer is running, and now I will make a post request. Okay, only thing, make sure that content type should be application or Kafka JSON that you are configuring, and then here I can make a send request. Okay, so see, name 1, 2, 3. How it is coming? Basically it is coming from this particular value part, right? So what we are doing here, in this case basically we have our Kafka REST proxy running in an EC2 instance. Using that only we can publish the message in MSK cluster, but that particular REST proxy don't have all the support. Like for example, it will be very complex if we are using REST proxy for IP level filtering or using API key access based authentication, right? So for all those things, we can wrap this particular REST proxy API within our Amazon API Gateway API, and that secured API we can share to our client or third party partners or vendors, etc. etc. Maybe for example, let me show you, suppose what I can do, I can stop this particular Kafka console consumer, and let me just create another topic, and let me try to publish the message in that topic only. So to create the topic, this is the code, right? So what I will do, maybe the topic name I am passing hello world. Okay, right? So here what I will do, I will copy this one, and then here I will create the topic. Okay, so here the topic will be soon created in our MSK cluster, and now I will start our Kafka console consumer for the hello world topic. Okay, so here this is basically our Kafka console consumer. So here topic name I'll be updating to hello world, and then here I will start the Kafka console consumer. Okay, right? So here it will start listening. Now suppose we have given this particular API to any third party vendor or partner, and they want to publish the message in hello world, for example, this particular topic, which name I will be copying, just now we created, right? So the main URL is not getting changed, just the end part they need to change, in what topic they want to publish the data. Okay, so first time we are publishing this particular messages in this particular topic, so we should be getting the offset as 0 for this particular message. Let's see. So when we will send the data, see in this newly created topic, we can easily publish the message using REST API. And if you just observe the output, what it is returning offset 0 because this is the first message, right? So for example, I can publish multiple record like this way. Value 1, 2, 3, 4, 5, 6, and maybe for example 7, 8, 9. 2 records I am passing. Okay. So here what I will do, I will just send it, right? See 7, 8, 9, 4, 5, 6. So that's the beauty of API Gateway, Kafka REST Proxy, and MSK. The MSK power is we no need to think about broker availability, whether broker is down or not, or zookeeper whether it is working properly or not. AWS is managing that. We no need to worry. And then here API Gateway has wrapped our Kafka REST proxy and made it more secure. Now if you see this particular URL is HTTPS, so it is more secure. Earlier the API, which is basically our Kafka REST proxy, that one was HTTP, right? If you see here, let me just show you. So this is basically one HTTP API. We converted that to HTTPS by wrapping within API Gateway. And now all the functionality of API Gateway we can avail. IP level filtering, IAM based authentication, API key based authentication, maybe cognito user pool also you can use, all these things. So if you want, you can explore this particular blog in detailed manner. So obviously they consider the security point of view also. Like in our MSK cluster, we give unauthorized access, but in this case, they have configured the certificates, trust store, key store, etc. to make it more secure and production level ready. But I hope you got some idea how to start working with MSK cluster, EC2 Client Configuration, etc. etc. This is what I wanted to discuss today in this particular video. Hope you understood this. Please terminate all the clusters, EC2 instances, whatever you have launched to avoid unnecessary cost. And if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.